pause, and then I have a introduction to actual topic, fundamentals of graphical user interfaces. Graphical user interfaces or GUIs. So many of you are using some sort of graphical user interface at this very moment. You can see and think about it a little bit. What graphical user interface it is. Something on the phone, using the touch screen, maybe on your laptop, maybe in some case something else, smartwatch maybe even. How is it used? What are the input devices and what are the output devices that you are using? Like mouse, touchpad, touchscreen, on. Then what are the elements? The interface consists of what sort of interface components and other graphics there are. And what style of interface is it? Is it like Windows icons, menus, and pointers, the classical desktop, or touchscreen interface, or maybe something else? So, yeah, if you are using that, you can do a little bit of a thought exercise, or maybe just imagine or try to remember something you used recently. Okay, here I have a couple of generic points that will be relevant for all this and maybe probably familiar to you already. Coordinate system is something that you need to use to some extent, and to draw graphics, but also the position elements, and then you need to specify colors. We will see in practice how these are, and most of this work can be done actually without explicit reference to these, but it's good to learn things. So for the coordinates, couple of things. The origin is 1 point. Where is the coordinate 0.0? In most cases, it's in the top left corner. So that's when you start calculating. And then the x coordinates go that way and y coordinates go that way in most cases. In some IPIs, the origin is in the bottom left, but I don't think that is the case in any of these. Then, of course, you can provide positioning with relative sizes and positions. So talking about like percentages of how many percentages of this width and height you want the component to be, for example, which helps it to scale. Instead, if you tell it that, okay, want it to be this many points wide, then it's kind of fixed size, and usually that's not what you want. At some point, line widths and font sizes need to be specified as well. These are usually specified with points. Point is actually actual physical measurement, 1/72 of an inch, or there are actually 2 specifications for that, but it is a small point. You know about what the like 12-point font, for example, is, so that gives you a rough idea what it is. And colors we are specifying, and those are probably familiar with these from anywhere where you use colors in computers, like drawing programs or web design or whatever. But yeah, the RGB color system is used most often. That's what the display uses, red, green, and blue. But there are different ways to specify that, for example, in the hexadecimal format, in the web standards, or just the numbers. Sometimes, yeah, the hexadecimal, so this specifies the red, green, and blue to numbers for each, and they are hexadecimal, so they go up to F16, but it can be between, in some notations, between 0 and 1, and in some notations between 0 and 255. And in addition to red, green, blue, you also have red, green, blue, alpha, where alpha refers to transparency of the color. So if it's totally opaque, you like blocks the whatever is drawn over completely, or if it's like somewhat transparent. Also, in many cases, you can use different color systems like hue, saturation, brightness values. But we will see concrete examples of these when they become relevant. Then, if we go to this very fundamentals of programming graphical user interfaces. So you're using some graphical user interface right now, possibly. Not all of you, maybe. When you give an input to the system, what kind of, how can you do that? Maybe you can click a mouse button, touch with the finger, hit a key in the keyboard, maybe some other ways. Then if you think what happens behind the scenes, what information is generated when you do some of these things, so that program can react to that. And when is this information sent to the user? No, I mean to the application. It's quite trivial maybe to think if the user clicks a button, obviously that creates some sort of a event. As said, all this is transferred as an events to the system. So when the user clicks the button, an event is created. That event tells that, okay, now the user pressed the mouse button down, for example. And this event includes some additional information, but then there are events also that happen more often, like when you move the mouse over the interface. Actually, every time the mouse cursor moves, a new event is created. So like 60 times per second, you get a new event telling where the mouse is, if the user is actually moving it, or user moving finger across the touch screen. And yeah, the keyboard, when you hit the key and when you release the key, but also if you keep the key pressed, then actually the operating system which keeps those repeating things, and you just in the application receive events several times. That okay, key A. So the events are things that encapsulate the information about something that happened, and then this is sent to the application so that the application knows that now I might need to react to this somehow. So mouse click is one example, mouse moving, finger touching, keyboard is pressed, released. Also timers, so if you want something to happen later in your application, like 1 second from now, you actually get an event that, okay, now the timer fired. In application programming, in the programming level, these are objects in the languages where you have objects. So you get this new variable into your application, and this some function or method gets called, and it gets this object, and then your program can do something. And this code, which actually make things happen, is called event handler. So when the user does something, an event is created, and this goes through kind of a fat layer of software. There is the operating system and the device driver somewhere in between, and then there is the user interface framework you are using. It receives some sort of events from the operating system, and then the framework does something to those, and then finally the framework calls the event handler, and this event handler is where you write your code. Event handler is where you specify what the program should be doing when the user, for example, clicks a button. And the event handlers in pretty much all interface programming, they are registered to these different interface components. So you don't write a one generic event handler that, okay, whenever the user clicks the mouse, this massive piece of code will decide what will happen. Rather, you write an event handler of that when the user clicks this button, this thing will happen. And when the user moves the mouse over this component, this thing will happen, and so on, so that you only think of the individual cases, which of course makes the code easier to maintain, that you don't need to try to think of everything. You think individual bits, parts of the interface one by one. The event handler you wrote receives the event, so that particular function is called when that event is created, and it receives the event object, and that contains additional information, like if it's a mouse-related event, a mouse event, the event object tells that, okay, the mouse was in these coordinates when this happened, and it was this button, this mouse button, that was clicked or pressed down or released, and so on. And yeah, the handler implements the actual functionality. Most of your code will be in these event handlers. In simple applications, it can be all in event handlers, basically. Well, some initialization code usually. And we will not go very deep into this because you don't need to do that much, but in most of the frameworks, your event handler can also decide what will happen to that event afterwards. So usually it is so that these components are in some sort of hierarchy. You have window, you maybe have some panel in there, and then you have a button, and if the user clicks the button event handler receives the event, but depending on how you have configured the system and what the event handler tells, then maybe also the window may receive that same event afterwards. But usually you don't need to think about this, how the events go up and down in the hierarchy and down and bubble back up. But I think we will mention briefly about that, but usually you don't need to worry about that. One note, and we will go deeper into this, is that when you are writing code for the event handler, you should write only code which can be processed immediately. So it shouldn't take a long time to process. This is because the user interface is not updated until your code has completed. So if you write a code which does lots of computation, the user interface actually freezes until your code is done, and obviously we don't want that to happen. So heavy processing should be in a separate thread in a safe manner, and as said, this is the separate topic, one module specifically kind of more or less dedicated to this. There will be other things discussed that week. But yeah, so the event handler should do only very quick things, and then do time-consuming things in a separate thread or through some asynchronous API which just starts this process. And those who have done any web programming, any JavaScript programming in the HTML or web pages, you may not have realized, but each and every API call, each and every operation which can take time, loading something from the net mostly, all those are asynchronous, so you just tell them that, okay, start getting this information from the internet. And then once the thing is loaded, then call this another event handler. So that by default is designed so that it's hard to create things that take lots of time. You just have to write some very complex loop, for example. But closer to the concrete. Let's see. Oh, yeah. I have here 4 implementations of event handlers. First is Java effects. Here we have a class that extends application. So this is a graphical interface application. It has start method where I have written the setup code. This builds the interface. I have some variable euros text field there, and then for the text field, I define set on action. So now I'm registering an event handler. Now, whenever this action happens on this text field, this code here is called. And what is this action? Well, this action is more kind of generic event. For buttons, action means user clicked it. For text field, it means that user was editing it and then hit enter key. And of course, there can be lots of different events or things you can listen to. On action is the kind of the default one, but there are like was it 30 something different things you can listen to. And then here is the actual code, public void handle, and here we get the event, object, action, event. And here I'm passing the text of the euros. I get the text out of that, put it in the float, convert it, make it the string, and then, well, it's not visible here, but there is another text field, dollars, and I set the text. Simple code can process pretty fast. What is probably a little bit challenging here for some, if not many of you, is that this notation here may look a little bit unclear. We have this new event handler, action event, with this kind of notation, and then curly brackets directly. And this is an anonymous class. How many of you are familiar with anonymous classes in Java programming? None of you. That's perfectly fine. I will talk about a little bit about anonymous classes and what they are, and why we are using it. We are using it because it's a more compact way of doing this. I think I will show some examples of how to do it without anonymous class. But the anonymous class whole point is that it's a more compact way to write code where you, well, here I want to do like basically 3 lines of code. It would feel a little bit stupid to create totally separate class just to specify these 3 lines of code. So with anonymous class, I can define the class. In this bit, I'm actually defining the class so that the code can be kind of put into the same space. But most of this thing during this course, you can just follow the examples and templates, and that should work for you just fine. But I try to explain a little bit more about the anonymous class, and you can go and read about it. Here is the example, very same thing about for the React. Again, we have the euros variable here and a function to update it. Here is an event handler code using this arrow notation. How many of you are familiar with the arrow notation in JavaScript? Yeah, that's quite a lot of more commonly used. So it's not, again, way to, in a complex manner, specify a function. And here I'm again, well, I'm getting actually from the event the new value by setting it into this variable, and then calculating the dollars value. So this is simple currency converter. I will be going through this demo program tomorrow in the lecture. And then here is the return statement. So this will continue further, but here I'm returning the actual user interface using this JSX notation. So it kind of looks like HTML. You have these tags inside the code, and I think I will skip those because they are not so relevant, but it's a similar thing. Well, a little bit different code there, but examples from Android programming and CK Inter programming. User interface component, as said, these are important part here, and there are different libraries, but the same fundamental components, of course, have existed since the 80s at least. We have buttons of different kinds, text fields, text areas, sliders, but also container components, so components which can contain other components, like some sort of panels that you can use to group other components together and put borders around them and so on. The components themselves take care of drawing themselves, so you don't have to worry about how they are actually shown to the user. You just add the component in the interface and provide necessary parameters, and there it is. And components have a way to register the listeners to them, event handlers. So I think I'm using two words more or less interchangeably. So event handler and listener, or event listener as the full word. In most cases, those are exactly the same. In some uses, you can find some nuances between the meanings of these terms. There are also in different frameworks different names for the user interface components. In some places they are called widgets, and in some cases controls. Hopefully I'm not confusing people with those. Well, at least for me it's quite clear what it is, even if different words are used. Yeah. Then layout, as I mentioned, is one aspect of the interface, and in most cases, and in this course, we are using the program code to define how the interface will look like, and to some extent some markup languages. As said, there are graphical user interface building tools, but this year we are not using any of them. For the Java effects you can, as said, download one if you want to. And yeah, there are these different components. We will look at examples which help you define how the interface is built. The very first one we will look at is grid. So you just have grid of components, and then you can maybe combine some cells one way or another, and then that way define the layout, how the different components are related to each other. But there are others, we will look at this. And yeah, with Java effects, we will at least quickly look at the XML-based markup language, how you can define the user interface. Style sheets are one thing that you probably at least have heard of. CSS, cascading style sheets that are used in the web programming. You can use those in React, but with Material UI, you kind of wrapping them into the styles components. We will look into that. CSS files can be used in Java effects as well, but the actual content of the CSS is quite different. Well, maybe not quite different, but the actual keywords and values are different, what you put in there. But I will be talking about this next week, and hopefully showing examples which explain things. And the scalability of the interface, as said, is perhaps the most challenging part, how you create an interface so that it looks good and usable in different sizes. So quick example. I just like to scale the task manager in Windows. It's not the best scaling, but at least it scales a little bit. You can try scaling different user interfaces next time you are working on a computer, or maybe on your phone if you're just rotating the screen, some interfaces do that. Examples, as said, we will go this into more detail next week. So, but here, grid pane is one of the things in Java effects. You can get the inset, so how much space there is between the grids and vertical gaps there, and how components align into this grid. And then we add components to the grid, telling to which grid cell they go, and optionally here, if they should take more than one grid cell. And box components are available in pretty much every framework nowadays. So box is something that binds together things. If you want to put things side by side, you can create a box and just put things in there. And usually you have vertical and horizontal box. So if you want things on top of each other, you create a vertical box. We will look this in more concrete terms over the course. So if you're using some interface right now, maybe you can try scaling it and see what happens, and how do you think it's defined, how that interface is defined so that it scales reasonably. Or maybe it doesn't. Okay, so to summarize, I talked some of the key aspects which are probably somewhat abstract at this point, but will soon get very concrete when we start actually programming. Events and event handlers. So events happen when the user does something, and event handler is the code you write, which then actually decides what will happen in the program when that event happens. And yeah. And layouts, how the components are laid out. So hopefully you're familiar with those words now, and then it will get more concrete soon. So next steps, hopefully you can decide which track you want to work on, JavaFX or React. If you want to, you are free to mix and match and do exercises from both. But it will be quite a lot of work, I guess. Then you should go and install the relevant tools. I will show quickly some instructions which will be in the Moodle after this meeting on how to install the relevant tools. If you have trouble installing the tools, I will be there in the exercise room this Thursday, starting 2:15. So you can come there and I will help you with the installing the tools. Of course, we don't have exercise meeting yet this week, so this is totally optional, just to make sure all of you can get started and can install tools. And of course, you can come there and start working on the first set of exercises. Those will be published tomorrow latest. And yeah, I can help you with any initial problems you have. So tomorrow, I said, 10 o'clock, I will talk about JavaFX, and 11 o'clock, I will be talking about React. Typo there. But yeah, React, and then in the following weeks, it will be Mondays, JavaFX, Tuesdays, React, and then exercise sessions for both of them. And then start working on the exercises, either 1.1, 1.2, and 1.3, or if you are confident of your skills, then you can choose 1.4 immediately. Okay, I can quickly show still these installation tools. I will publish this as said soon. So yeah, I don't go to any details, but hopefully these are